Hi guys, 8.3 Logarithmic Functions as Inverses. This first video will be covering the first objective to write and evaluate logarithmic expressions. For most of you, this is probably brand spanking new. You've never heard of logs, and this will be your formal introduction. For those of you who've heard of logarithmic functions before, hopefully this will just be a refresher and get those gears going. All right, without any further ado. Oops. Okay, example 1 is dealing with the Richter scale and the formula that they use in order to compare the amount of energy. Because we are not seismologists, I'm not even sure if I said that correctly, but because this is not our daily thing, we do not have these formulas committed to memory probably. If you do, you are spectacular. All right, the formula that we're using, or the ratio, is E times 30 to whatever the number was on the Richter scale. Now, and so the 8 to the 6.8. So now the e's cancel out because they are like terms. E times something, E times the e's cancel out. And with dividing powers with the same base, we keep the base, subtract the exponents, and we have 30 to the 1.2. You put that into the calculator and it says 59.2. So the earthquake in Mexico was about 59 times as much, or released about 59 times as much energy as the earthquake in Washington. Okay, so for us, compare the amount of energy released in an earthquake that registers 6 on the Richter scale with one that measures 3. All right, so we know that we have that E times 30 to the 6th, because that's what this one is, and then all over E times 30 to the 3rd, because that's what this one is. Now, don't worry about memorizing this formula because you're not going to need it. At least you're not going to need to commit it to memory. But it is cool to see how it's used in the real world, especially since we live so close to the New Madrid Fault. All right, now the e's cancel out, and we have 30 to the 6th power over 30 to the 3rd power. Same base, so we keep the base and we subtract the powers. This gives us 30 to the 3rd power, which is going to be 27. Oh, heavens, I don't want to mess it up and make a fool of myself. I do it so often. 30, raise it to the 3rd power, and that is 27,000. I was going to say that, but I was afraid I'd be wrong. Miss a zero somewhere. So we have 27,000. That means the amount of energy released in an earthquake that registers 6 on the Richter scale with one that registers 3 releases 27,000 times as much energy as that one that registers 3. That is crazy. Okay, let's go ahead and go on to example 2. Oh, before we get there, let's do the definition. The logarithm. Okay, logarithm we usually just refer to as a log, and this is the logarithm to the base b of a positive number y is defined as follows. If y equals b to the x, then log base b of y is equal to x. Now, if you take a look at that, all of the different elements are represented. So if you commit this if-then statement to memory, it will make your life so much easier. Okay, all right, let's see this in action. All right, so taking a look at the textbook example, write 25 equals 5 squared in logarithmic form. Well, like it is here, we know y equals b to the x, so this means this is the y, this is your b, and this is your x. And we need to write it as log base b of y is x. So we replace that b with 5, we replace the y with 25, and we replace the x with 2. Here you go. And that's it. Okay, so I'm going to write this again just so that you guys see it, and I want you to get into the habit of writing it yourself on your homework problems because that will help you commit this to memory. But take it from take my word for it, please. Okay, now taking a look at this, we have 32. So this would be the y. 2 is our b, and 5 is the x. So writing this in logarithmic form, we have log base b, the base is 2, so 2 goes down here, of y, which is 32, equals our exponent 5. There you go. So log base 2 of 32 is 5. That's it. Oh, not new. There we go. All right, now evaluating these log functions. Okay, so you got log base 8 of 16. Well, we know that this is equal to x, right? It's equal to something. It's equal to some power. So we have 16 is equal to 8 to the x power. We are going to convert this 8 to 2 to the third, which if you remember a few chapters back, I said it would be a good idea to think in terms of this as opposed to that. And we have 2 to the fourth is equal to 2/3 x. So we set those equal. 2 to the fourth equals 2 to the 3x. They have to have the same basis. If they don't have the same basis, then you really can't proceed. So now we can say 4 equals 3x and solve it for x. Okay. This one for your notes here is actually going to be pretty easy, so we'll do the one down below as well. So we have evaluate log base 3 of 81 is equal to something. So we know that's going to be 3 to the x equals 81. Well, I know 81 is 9 times 9, which is the same as 3 to the fourth power. So we have 3 to the x is equal to 3 to the fourth. So therefore x equals 4. All right, let's talk that through because I know that was kind of fast. All right, so log base 3 of 81, which we have here, is equal to x. It's equal to something. This is your base, this is your power, and then this is your, I should say, this is your base, that's your exponent, so this would be your answer. We know 81 is not a prime number, so we want to rewrite it in terms of prime numbers, and that's what this was over here. So then we took this and rewrote it as 3 to the fourth. They have the same base, so x is equal to 4. All right, let's do another one. Let's do A. A's not so friendly looking, is it? Okay, so we would have this is equal to x. So we have 64 to the x power is equal to 1 over 32. Well, these aren't prime, and they're not perfect squares, and let's go ahead and look at this in terms of base 2, right? Because 64, we know, is 8 times 8, which is 4 times 2, 4 times 2, and this is 2 times 2, and 2 times 2. So that's 1, 2, 3, 4, 5, 6 twos. So this is going to be 2 to the 6th power times x equals 32, you know, is 8 times 4, which gives us 4 times 2, which is 2 times 2 times 2 times 2 times 2. So 2 to the 5th power. Now we have the same base here. So that means we can set these equal to each other. So we have 6x equals 5. Solving this for x, we divide it by 6. So x equals 5 over 6. There you go. That would be the answer for A. Okay. Let's go ahead and look at example 4 so we can move on. Oops. Okay. All right. A common logarithm is a logarithm that uses base 10. If there is not a base listed, then it is implied that it is base 10, just like if there is not an exponent written on a variable or a base, it is assumed, it's known, that that would be, excuse me, the exponent would be 1. If you have x, y, z, you know that the coefficient of that is 1, right? So common logarithm is log base 10 of y, or just log y, right? Okay, another real-world application of our wonderful logs. The pH of an apple is about 3.3, and that of banana is about 5.2. Recall that the pH of a substance equals negative log H plus, where H plus is the concentration of hydrogen ions in each fruit. Which is more acidic? All right, the pH of an apple is about 3.3. All right, let me scroll up because this is what I haven't done in a while. That's how I was going to set it up. So, all right. Let's go ahead and write these out as two different things. We have our apple, and we have our banana. This one, the pH equals negative log H plus is equal to 3.3, and this one is negative log H plus equal to 5.2. We are going to want to convert this to a positive, so we're going to have log multiply through by -1, or add this and then subtract that. So we would have log of H plus is equal to negative 3.3. Log of H plus is equal to negative 5.2. All right, well, we know that this has base 10, so this would be 10 to the negative 3.3 is going to give us the number of hydrogen ions. And likewise, this one over here, with this one being base 10 as well, it would be 10 to the negative 5.2. That's going to give us the number of hydrogen ions for a banana. Now, with respect to which one is more acidic, if you were to multiply these out, let me see, I'm pretty sure that, yeah, that's not going to work on that one. So 10 raised to the negative 3.3 is 5.01 times 10 to the negative 4th. So 5.01 times 10 to the negative 4th. 10 to the negative 5.2, we're going to know is going to be it's going to be significantly smaller. So we've got negative 5.2, and that is 6.31 times 10 to the negative 6. So 6.31 times 10 to the negative 6. Since the apple has more hydrogen ions, the apple is more acidic. All right, that's it for these examples. I know it's overwhelming, but practice will make perfect, and this is something that you will be able to do and do successfully.